This is geometry level 3. This is where I'm going to be using congruent triangles to prove facts about quadrilaterals. We're starting off with quadrilateral ABCD, and they're telling me right off the bat that this is a parallelogram. This means that the opposite sides are parallel to each other. My goal is to prove that not only are the opposite sides parallel, but I need to prove that the opposite sides are the same length, are equal in size. So I've written down the first fact about those sides. I'm going to use those parallel sides along with a diagonal of that parallelogram to help me prove that the opposite sides are equal in length. So now I've got two triangles. If I could prove that the triangle on the bottom is the same as the triangle on the top, so they look like twins except one is rotated 180 degrees about the other. If I could prove that those two triangles are exactly the same, then I would know that these two sides are the same and these two sides are the same because of CPCTC. In order to do that, I'm going to use the fact that DB is congruent to itself. DB is in both triangles, so it must be the same in both triangles, and we call that the reflexive property, which gives me a side matching with the side. I also know that angle 1 must be the same size as angle 2, because since opposite sides are parallel, the alternate interior angles must be the same. I'm going to use the same logic to say that angle 3 is the same size as angle 4. So my reason would be that alternate interior angles are equal. Now looking at the pattern that I have here in my triangles, I've got an angle and a side and an angle, matching with an angle, a side, and an angle. So the white angle, the green side, and the blue angle match up with a white angle, a green side, and a blue angle. So now I know that the triangles, triangle ABD, must be exactly the same, must be congruent in size and shape, exactly the same. ABD is exactly congruent to triangle CDB. And the reason is because of the pattern, angle, side, angle. Now that those two triangles are known to be twins, the matching parts of one triangle must be exactly the same. So the opposite sides are equal in length. And the reason is because of CPCTC. All right, and this next proof, to prove that the diagonals of a rectangle are equal in length, we're going to do a very similar proof as before. Using congruent triangles, we're going to prove that those two blue diagonals are exactly the same. The trick on this question is making sure that you're using the correct triangles. To prove that those two blue sides are the same, I'm going to use triangles that have those blue sides. So this triangle with the yellow freckles inside has this blue side as one of its sides, right? Now I need another triangle that has this as one of its sides. So I'm going to use the mirror image triangle over here, which has this as one of its sides. I'm going to prove that this triangle here is the same as this triangle here. To help show that, I'm going to decorate the other triangle a little bit differently. Let's use like a little lightning bolts, I guess. So I have to prove that the triangle with the white lightning bolts in them is exactly the same as the triangle with the yellow freckles in them. And to do that, I'm going to use side, angle, side. It is a rectangle, so I know for a guaranteed fact that these two sides are the same. So RT is the same as EC because opposite sides of a rectangle are equal. I can also use the angles that are in each of these corners right here. I'm going to have to call that with 3 letters. Angle RTC has got to be the same as angle ECT. So I'm talking about these angles down here in the corner. And hopefully I didn't lose you on that. I'm calling that angle RTC. These are the 3 letters that make up the angle. This one's ECT. The reason why that is correct is because all angles in a rectangle are equal to each other. They're equal to 90 degrees. So what am I sitting on right now? I'm sitting on a side and an angle, and a side and an angle. I need one more piece. Looking at these 2 triangles here, one thing to notice is that those 2 triangles both share something. They both have something in common. They both go over C to T. So as I trace around this triangle here, CT is one of its sides. When I trace around this triangle here, CT is one of its sides. So what I'll write is that CT is equal to itself. And there's my good old buddy, the reflexive property again, giving me that extra side that I need. If I keep score on what I've got so now, I've actually got enough to actually prove it. Because I've got a side, angle, side pattern, I can say that the triangle RTC is congruent to triangle ECT. And the reason for that is because of the side, angle, side pattern, which now unlocks the reason CPCTC. Now that I've got the congruent triangles, now that I've got the CT, I'm allowed to use CPCTC to mention parts that must be the same. So it's a guaranteed fact that RC must be the same as E to T, and that is because those blue sides are the matching sides, the corresponding sides of the congruent triangles. Done. For the final proof, I'm going to prove that the diagonals of a rhombus are perpendicular. To answer this question correctly, you have to know what a rhombus is and you have to locate the two triangles that are most important to solve this problem. So let me look at just the very beginning here of what a rhombus is. The basic definition of a rhombus is that a rhombus has all four sides equal. So I do get all those sides as matching sides. Before I actually write anything else down, let's discuss why I'm going after these two triangles here and here. I could prove that these two triangles are congruent. If I did, it would prove that this angle here is the same as this angle here. Just because those two angles are the same does not mean that they're both right angles. So what I want to do is not use those angles, but instead use these angles here. If I could prove that these two angles here and here are equal, I would know that those make 180 degrees altogether, and if they're equal, then this angle and this angle must split the 180 degrees evenly to 90 and 90. So that is why I'm going after these two triangles, to prove that there are right angles happening where the diagonals meet. I could have picked these two or these two triangles. There are different possibilities, but these are the ones I decided to go after. Choosing these triangles would not work. Choosing these triangles would not work. They have to be angles that are side by side. So this is what that looks like when we put it all together. I'm only going to use parts on those dotted triangles. So RM is definitely the same size as RH. And that's because a rhombus has all sides equal. Rhombus has four equal sides, or four congruent sides. Do you see the reflexive property happening again? I do. RB is equal to RB because of the reflexive property. So that gives me two sides that match up with two sides. I just need one other part in both triangles. There's a couple ways I could actually finish the question with. I could actually say that BM and BH are the same because a rhombus is a parallelogram and a parallelogram has diagonals that bisect each other. So I could actually say that these two sides are the same and use side, side, side to prove the triangles are congruent. Another thing I can do is prove that these two angles are equal because in a rhombus the diagonals bisect the angles. I'm going to use that one for this one just so I can finish up with some A's in the picture too. So let me resize my cursor. I'm going to prove that this angle is equal to this angle and write that down in my picture, or on the side here, that angle MRB is the same as angle HRB. And the reason is the diagonals of a rhombus bisect the angles. So now I can actually finish by saying that triangle MRB is congruent to triangle HRB. The reason is because of a side angle side pattern. And since that's true, angle RBM is equal to angle RBH. And that's because of CPCTC. That doesn't prove that those angles are right angles, but since these two angles form a straight line, I know that they must both be equal to 90 degrees. And because that's true, I could write that RB is perpendicular to MH. So those diagonals definitely are perpendicular. The reason would be it takes a little while maybe to write down the answer in just a short little form. The quickest way I can maybe think of writing it would be that two equal linear angles must be 90 degrees each. All right, hopefully you've gotten something out of these first three levels. It's quite possible I might add more to them in the future. So keep on working at getting stronger in geometry. You can do it. It may require watching these videos more than once to actually soak up all the different details that I'm throwing out.